1, 2, 3. 1, 2, 3. And it looks like we are live. There we go. Okay, and we are live. All right, so today we're going to do a pretty quick repair just because we have a long list of customers today. But I wanted to do a 2011 failed GPU graphics bypass using Diagnostic Tools Gmox. It's basically a graphics card patcher where we're going to reprogram the Gmox chip, which is responsible for switching between the AMD graphics card and the Intel integrated graphics. So first thing I'm going to do is go ahead and show you. I have a 2011 15-inch MacBook Pro here that does have a failed graphics card. And how we can check that out is if we have any weird lines, discoloration. I'm going to try booting this one into safe mode. And this one has some very obvious blue lines in the screen. This is a very common issue with the 2011 graphics cards. Both the 15-inch and the 17-inch MacBook Pro are known for this. The 13-inch doesn't have it because it doesn't have a graphics card. It just strictly uses it as integrated graphics. Also, the iMacs, the 2011 iMacs, are notorious for this too. So you can kind of see here, we got some flashing, weird discoloration. It looks more green in person, and I do have some lines, but this isn't going to load up all the way because the graphics card is essentially dead. So what we're going to do here is we're going to end up bypassing by using a couple of different methods here. So first thing we want to do is we're going to need a Lattice programmer. And this can all be found on DasDude's website. So we have ourselves here a Lattice programmer. It comes with these wires. There's an instructions on his website too on how to do this. I've gone ahead and hooked the wires up to a terminal that we are going to solder on to the logic board. And this is the male adapter. The female adapter we're going to put on the logic board side, plug it in, and then go ahead and run the software. So first, let's go ahead and take a look at what you guys would be looking at by going to his website. So let's go ahead and pull that up. Sorry, I have something pulled up here, so let me move that out of the way. All right. So on our screen here, we have DasDude1.com. So there's a couple of different things here, but really what we're looking for is going to be resources. And here they talk about some programs disable your MacBook Pro dedicated GPU through the NVRAM, but really what we're looking for is the Gmox method of permanently disabling the 2011 15-inch, 17-inch MacBook Pro dedicated GPU. So this website is going to have everything we need to know about bypassing the graphics card on the 2011 MacBook Pros. It just kind of goes through some important notes here, the 15-inch version versus the 17-inch version. It shows where you can download their software, pay for their license key. The license key is only $20. It's definitely worth it in my opinion. And then also talks about the programmer where you can purchase one. Let's see, right here, the Lattice HW-USBN-2A ICSP FPGA programmer, and you can buy one right here at this link. So I've already gone ahead and purchased a license key. So we are good to go here. And these are just kind of the step-by-step instructions on how to do this, but we're just kind of making our own how-to video here. So let's go ahead and get started. Basically what we're going to do first is we're going to get these female terminals that I have bought from Mouser that is going to solder onto an unpopulated terminal on our logic board. So let me bring over our microscope camera. So that right there, let's get this in focus. Okay, so this is our Gmox chip. This is what's responsible for sending power between the integrated graphics or the dedicated AMD graphics card. It's also just responsible for switching but between the two graphics cards. But if you look here, there is an unpopulated terminal where Apple themselves would actually program this Gmox chip. And so DasDude, Colin, and I'm so sorry I forget his colleague's name, have reversed engineered the firmware on the Gmox to be able to bypass the AMD graphics card. Just through firmware, essentially, we are going to be disabling the integrated or the dedicated graphics card. So let's go ahead and start with soldering on a new FPC connector. So what we're going to do is I'm going to heat up the general area first with some heat using a rework station. That way we can make the ground area here at a higher temperature so that we can melt it with a soldering iron. And so I'm just using around 450 Celsius heat because I've left it in the case. I don't want it to get too hot to where it melts anything else in here, like the keyboard on the other side. And I'm really just trying to raise the ambient temperature of this logic board so that it's going to be that much easier for us to solder on our female terminal. All right, let's go ahead and turn on our soldering station, our fume extractor. Go ahead and put some flux down. Now, I'm going to just very briefly tin up these pads with some leaded solder. And now, we're going to grab one of these female Molex terminals. Kind of what I found that's been helping me lately is I actually tin up these pads as well, or the actual pins on the Molex terminal, specifically the ground. So I'm just going to put just a little bit of flux right there. And now we're just going to very gently touch that up with our soldering iron. Let's wait for it to get to temperature. We'll hear a beep here momentarily. Any second. Cool. And now let's just very gently put a little bit of solder right there. You don't have to do that. That's just a step that I personally do to make soldering the ground connections a little bit easier. And then now we are going to line this up as best as we can. You could solder the wires from the Lattice programmer straight onto the terminal. You don't have to get the Molex connector, but I find this to be so much easier and quicker for doing any type of GPU bypass. Especially if you're doing them in large quantities for customers, this is definitely a much faster way to go. So then now, since our board should still be warm, I'm going to go ahead and just touch our tinned up ground connection. And we are misaligned, so I'm just going to shift that down a little bit. My hands are very shaky because since there's so much to do, I'm on my third cup of coffee. I've yet to have lunch. So that is something I will be doing shortly after this video. Come on, hands, work with me today. I'm actually going to go ahead and try soldering one of these pins down just to hold the Molex adapter in place. These pins are going to melt so much easier because they're not ground, so they don't need as much heat. Okay, so now those pins are down on the Molex connector. Let's go ahead and just start melting the solder here for the ground points. Same thing here. And then just briefly touch up the pins on our Molex. And then if you'd like, just to make sure that they're actually on there solid, do a wiggle test. Just kind of poke, and if it feels like it's wiggling more than it should, then you might need to solder again. And these all seem pretty fine. So we're good there. Let's go ahead and just clean that up a little bit with some isopropyl alcohol. Just put a little bit of isopropyl alcohol on a Q-tip here. And so our Lattice programmer is ready to be plugged in, but we aren't fully ready for us to actually start the programming. Let me try to get this more in focus again for you guys. Okay, there we go. So now the next step, what we're going to have to do is we're going to have to short our a specific line that I will tell you here in just one moment. Let's pull it up, because I forget the exact line. We want to short our PLT Reset L to ground. That's going to be our platform chip or platform controller, I believe. We're basically going to tell it, do not turn on, be in a constant reset mode, so that way we can go ahead and program our device. And so there is a diagram on this website of where they recommend for you to ground. So it looks like in this instance, there is a resistor right here, and then they're suggesting to short it to just any metal surface. There is another spot I personally like to use. So what I'm going to do is I'm going to copy this line, the net name, and we're going to go ahead and open up the schematics here, which I've preemptively done. This is a 820-9115. So now what we want to do is just look for all the different spots on this logic board. The board is still in the housing, so we got to look on this side. And so here's the resistor that is on the side that they were talking about. And if you wanted to, you probably could just run a wire from here to pin 2 on the resistor, since that looks to be ground. But there's another connection right here, and it's U2890, to where we can literally bridge pin 2 and 3 with just a tiny bead of solder that is going to short our PLT Reset L to ground. So let's go ahead and go back over to our microscope camera and look exactly for that part. And it should be that guy right there. Let's go ahead and just reference real quick to make sure that is the right spot. Let's go back on screen. So we have these resistors right next to it and one underneath it. And there's nothing populated right there to the bottom left, but we do have the 2 resistors there. So that is the spots that we want to short, and it's going to be specifically pin 2 and 3. So what I'm going to do is just very quickly get a bead of solder, just glob between the 2 pins. Just like that. So now our PLT Reset L is shorted to ground. So now we are at the point to where we can go back over. We can go back over to where our Lattice Molex terminal is at, and we can go ahead and plug our connection in. So here's mine. It's already made. It's just some cables that have a male attachment, and it's just going to plug in like that, and just so that you guys can see what it looks like in the microscope. Just like that. So we're fully plugged in and ready to go. So now what we need to do is plug this into our computer. It's a USB Type B connection. So let me grab that. And now we have a red light, and when it's ready for it to be programmed, it's going to turn into a green light. So before we actually begin the programming, we want to make sure our battery is disconnected, and just to make sure we're not corrupting data, we're going to unplug the hard drive or the solid state SATA cable from the logic board. Then, after that, we are going to go ahead and get an 85-watt MagSafe 1 adapter. It has to be 85 watt. A 60 watt will not power the board with the battery unplugged. It would require the battery. Oh, excuse me. So now I have the 85 watt connector plugged in. We can see the fan spinning. The computer is probably going to turn off here in a second. And nope, it's not. So we're actually in a good programmable state. We can see the lattice has a green light, so we are ready to program the GPU Gmox on this computer to basically just use in the integrated graphics. So now we have to pull up the DOS-Dude software, which can all, or the Gmox software, which can still all this be found on their website. So I've actually gone ahead and downloaded the software, and I have it pulled up right here. And I've already used my license key. It says it's good to go. It's good for one time. So once you pay for the license key, you go ahead and you enter it in here. It checks to verify it is a good license, and then we hit Flash Gmox. And this shouldn't take too long, typically about 30 seconds. If you get any errors, the errors are typically you don't have a good solder connection on the actual logic board, whether the Molex connector isn't on there properly, or if you're just soldering the wires from the lattice straight onto the pinout, you're going to have an issue. And it says right here, an error has occurred. Check your programmer connection. And so I'm going to do that one more time, but I'm going to push down on the Molex connection just in case something is not plugged in properly. And let's try again. Apply, flash. Error still occurred. So now what we're going to do is we're going to take a look and see why that error has happened. Let's go back to our microscope. I'm going to unplug power. And try to get this in focus for me, but also you guys. I have to lift my entire microscope up. Try to zoom in just a little bit more to see exactly what's going on here. All right. Now, let's go ahead and unplug this. And what I'm going to do is I'm going to touch up all the pins again. Let's get a little bit more flux on here. Because either I don't have a solid connection, or my PLT reset's not on there properly. I'm pretty confident in this case it's on there properly, but we're going to double check it again. So let's go ahead, touch this bead of solder onto that pin. We're good there. Same thing here. All right. So just went ahead and touched up those pads, make sure there's nothing obstructing. In here, we look pretty good. And we'll push this down one more time. And then let's revisit where we shorted our PLT reset. That looks to be pretty shorted. So let's give that a shot one more time. All right, so go ahead and plug in power. So I've connected the 85 watt, the fans are spinning, SSD is unplugged, battery is unplugged, and our lattice programmer is plugged in. Now let's go back over and flash the Gmox a second time. Error still occurred. With your connection, please read the important notes. And so this could be happening because of some other things I've experienced in the past. One, this USB Type-B cable might not be okay. Two, there might be an update for that software, because admittedly, I didn't download that software today. I downloaded that software last week for the last one I did. So I'm going to look for another USB Type-B connection that we have here to see if that resolves the issue. And if it doesn't, we're going to re-download the software. Okay. 1, 2, 3. Okay. I accidentally touched the front of this computer and looked like that I may have disconnected my audio. I'm so sorry. So hopefully we've had audio this entire time. But basically what I was saying is that the programmer for the Gmox flasher didn't work the first 3 times. And what we found out is that our USB Type-B connection that I had was just not a good cable. So I went ahead and I grabbed another cable and it seemed to work. So if you're ever having issues, you've paid for the $20 license, you've downloaded the software, the Gmox flasher, and it says it's not connected, check your solder points. If it still doesn't work, check your PLT Reset L connection that you did. Make sure that that's properly shorted to ground. And if it's still not working, check your USB Type-B connection that actually plugs into the lattice. And if it's still not working, check to see if you have the latest version of the Gmox flash software. So that was successfully consumed, and if we look on screen, you can see this license key that I use says it's consumed. If you're watching this video at a later date and you try entering this license key, it's not going to work because it is a one-time license key. So I went ahead and preemptively bought it before doing this video. So that says that it was properly consumed. So now this computer should just turn on. So what we need to do first is now we need to remove our short for our PLT reset connection. So let's go back to the microscope. And you can see right there we have a tiny little solder ball. And I'm just going to grab a piece of wick and attempt to solder that, desolder that. Sorry, I dropped some tweezers and looked like I bent them. That will be alright. Alright, so our pin 2 and pin 3 are no longer soldered together. There's no short on our PLT Reset L. So now, if we were to go ahead and switch over to our overhead camera, we have our Gmox has been reprogrammed, so this computer is not going to use the AMD graphics card anymore. Let's go ahead and plug in our SSD connection, plug in our battery, and now, as you saw earlier, there was all sorts of different discoloration. Let's go ahead and hit the power button. And this should just load up with no discoloration at all on the screen. Let's see. This model in particular, you have to hit the power button twice whenever the battery's been disconnected. So I got a gray screen here. It's not blue, it's not green. That is the gray Apple logo I want to see. Someone has already installed a solid state drive in this, so this should boot up relatively quick. Just to make sure we're not doxing any customers, I'm going to put my hand just right over here so that we're covering up any usernames. And look at that. They had automatic login, so we are going to hide all this for a second. And what I'm going to do is I'm going to navigate to System Preferences real fast so that we can see it is no longer detecting the internal graphics card. Yes, we know the time is wrong because the battery was unplugged, and why not? Let's just go ahead and full screen this blank Word document. That way it hides everything. Okay, navigate to System Report, and full screen this. Okay, so I'm now in System Report, and I'm going to navigate specifically to the graphics section. So normally on this model computer, when we go into the graphics, we would have 2 sections here. Let me actually change. All right, so we would normally have 2 sections here, one for the Intel HD graphics and one for the AMD graphics card. But this one is only showing the Intel, so it is no longer showing the AMD graphics card. This has been fully disabled. So the Gmox software is working. Now, we're not quite done. There is just a little bit of extra homework I would like to do. So even though the graphics card, the AMD graphics card that has failed, we've bypassed it. We're no longer using it. This is a fully working computer. The power supply going to the AMD graphics card is still present. And so even though this is turned off, the AMD graphics card is still getting power. So we want to disable that for 2 things. It's going to cut down on heating, because we don't need to heat up another processor if we're not using it, and it's also going to save on power consumption, so this is actually going to help out with battery life. So for that, we also need to reference our schematics, and all this information is also on DasDude's website as well, basically talking about where you can disable. I think it's near the end. Let's see where he talks about it, just so that you guys can see it. Drivers, installing the software. Actually, it is not on there, and I'm glad it's not on there so that I can show this to you guys firsthand. Okay, so actually, DasDude explained this information to me in the old Rossmann Discord, so it's actually not on his website. So I'm going to show you how you can fix this. So what we got to do is go ahead and pull up our schematic software here. We don't need that anymore. And so the graphics card is going to be right underneath this chip. So it's U8000 is our graphics card. U1000 is our Intel i5, i7 processor with integrated graphics. So we're really focused around this area. So let's go ahead and just right-click. Let's right-click this chip, this capacitor in this general area. Here we are, GPU V-core regulator. So voltage core regulator, this is going to be what generates power for, or the V-core for our AMD graphics card, which we are no longer using. So I'm not concerned about any of this information here. I'm really just looking at for VDD and PVCC. This is the line that generates power that turns on the rest of the circuit. So if we look at VDD, it is going to be PP5V S3 GFX IMVP6 VDD. It's a long way of saying power comes from our 5-volt line into these two lines. So we have two little resistors here. What we're going to do is simply remove those resistors. PP5 can't make its way at all to this circuit. It will never turn on the AMD graphics card. It will never generate heat. It will not supply power. We've already disabled the graphics card, so we're just going to go ahead and finish removing the rest of the power line. So let's go ahead and look for where R8911 and R8904 are. Let's right-click on it with our schematic software, and it shows right here, right around U8900. Our resistor is right here for U8911, so we're going to remove that. And then where is U8904, just so we know where that's at too. Pretty much right next to it. So U8904 is right here, U8911 is right here. So we're going to end up just pulling these resistors off. Well, let's go ahead and switch back over to our microscope camera for us to do that. Definitely make sure the battery is unplugged before you do any soldering work. I have seen people do board repairs with the battery plugged in. Don't do that. Okay, so here's U8900. This is the V-core regulator, GPU V-core regulator, and we are looking for this and this. So this was R8911, and that is R8904. We're just going to simply remove those. And I have some hot tweezers here. It's just soldering iron tweezers that we are going to use for plucking these off. So once we hear a beep, this is going to be hot enough to where I can just simply touch this and it's going to come right off. There's no ground connection, so I really don't have to worry about heat. Just lightly touch the resistors, and they're gone. And make sure that they're not bridged. Yep. All right, so R8911 and R8904 have been officially removed. So this graphics card has been successfully bypassed with the programmer and successfully removed with the voltage. Now, just to make sure it still turns on, let me plug it into our battery and boot back up. Now, you cannot remove those resistors without doing the Gmox first. Yes, it loses power to the AMD graphics card, but if the Gmox has not been properly programmed to only use the integrated graphics card, you're going to break something. I've seen people just remove those resistors and call it a day, but the second you do a PRAM reset, this computer just stops working entirely. So you have to flash the Gmox with the DOS-Dude Dmux software before you can remove those resistors. And just to cover this, to make sure, actually it's going to load his information, so I'm going to hide that real fast. And you just have to believe me when I say his information or his MacBook is fully working, since it automatically logs in. Actually, I'll just go back to system preferences so that you guys can see, or not system preferences, but system information, system report. Full screen this. And here we are. Still working MacBook with one graphics card. We go into the graphics display setting, only showing one card entry. It is not showing the AMD card anymore. It's just strictly the Intel integrated graphics. So that is how you do a bypass. Now, there are two major things that happen when you do this type of repair. You lose external display. That is a big thing that is controlled by the AMD graphics card. So when you remove the AMD graphics card from the equation, you no longer get external display through the Thunderbolt port. It's just gone. Another thing is you lose backlight control. Now, this has been fixed on DOS-Dude's website with a graphics or a backlight patcher. And I'll show you if we go back to his website where that's at. So here at the very bottom, when we're done flashing, there are steps here on how to install backlight control. So natively, if we were to try to control the backlight, I'm not going to get anything, no light, it's just completely disabled. So that's going to be the next thing I do. That's a whole nother video in itself. I'm just going to skip that. But once you do this repair, go back to the software or the website here, and you can see the steps on where to download the software. And if you're running High Sierra, which most people are on this computer, you do need to boot into recovery mode and through terminal disable the CSR util, which is the system integrity. You're just going to temporarily disable that so that you can run this package so that you have native backlight control. So that is it. That is a successful graphics card bypass. Just a quick little rundown again. Basically what we did is we soldered on a new Molex terminal on our logic board. We then used our Lattice programmer, connected this to our terminal next to the Gmox, and then we downloaded the software from DOSDude1.com. Under resources, there's a whole entire section that talks about permanently disabling the 15-inch and 17-inch 2011 MacBook Pro. You buy the license key for $20, download the software, make sure that PLT Reset L is shorted to ground. All this is on the website, and then run the flash software. Then after that, the extra little step of homework that is not on there is to remove R8911 and R8904, which are resistors that connect the 5-volt line to the V-core generator of the AMD graphics card. But you have to do the Gmox first. Don't just remove the resistors and call it a day. That is not a proper repair. You have to do the Gmox first. Too many repairs I've seen come in here from professional technicians that just simply remove 2 resistors, charge the customer $100, and they ended up with a broken Mac. So I hope this has been a very informing and informational video. And I appreciate you guys watching. I will see you all in the next one. Make sure to follow DOS-Dude, Colin. He has a whole entire YouTube channel where he probably does a better job explaining this. But I will see you guys all in the next one. Have a great one.